Welcome to this presentation. Today we're going to talk about UML Activity Diagram, brought to you by James Elvis and Becca Clausen. Okay, so speaking of UML diagrams, those diagrams are used to represent all sorts of things, and we can divide them into areas. We have structural UML diagrams that represents static things or things as they are, and we have behavioral UML diagrams. And those behavioral UML diagrams talk more about events, actions, things that are happening, and we can follow the flow of those things. Today, we're going to focus in one specific behavioral UML diagram, which is the activity diagram. There's a company called SmartDraw, that's the logo showing right there, that creates a software to create your own activity diagrams, and I'm going to be using some of their symbols to explain the representations. So imagine the flow of an activity that you want in your software or your function, and there are some specific symbols that you can use to represent what's happening, and then people reading the diagram can expect the same thing as they see those symbols. So let's go over a few of those. So we have the start point or initial state. It's represented by this little dot with an arrow. So in an activity diagram, it's always going to start at this dot, and then it's going to point to the direction where the activity is going. Then we have an actual activity. It's represented by this rectangle with the rounded corners. So these activities are going to be named there when we can follow the flow. To follow the flow, we're going to have an action flow represented by an arrow. We have also an object flow. So object flow refers to the creation and modification of objects by activities. An object flow arrow from an action to an object means that the action creates or influences the object. Then we have a decision symbol. The action will go to the symbol, and depending on the decision, and it's going to send it to one direction or the other. We have guard symbols. So in UML, guards are a statement written next to a decision diamond that must be true before moving to the next activity. When a specific answer, such as yes, the labels are printed before moving forward. So in guards, we can specify what type of answers are going to happen in this diamond. Okay, synchronization. Sometimes we have multiple activities happening at the same time. So we have a fork node, which is represented by a thick line, and then from this fork, several activities are going to happen at the same time. And we can also add a join node, so we have multiple activities that converge to a single activity. So they are happening independent of each other, but there's going to be a point of conversion. We have a time event, and it's pretty obvious. We have this hour loop or hour class, and this represents a time event. So let's say your application is going to stop for 30 seconds while trying to connect to the server or something. You can represent that by a time event. We have a merge event. So this one is different. And it's not the same thing as the fork, the join node, because in the join node, those activities, they are happening independent of each other. In this case, all activities need to be completed before the merge can happen. So an example is the validation of an email and a password. If one doesn't work, the other won't be able to continue as well. So they all have to be true, so you're going to be able to merge and continue throughout your activity. This one is very important as well, which is the signal sent and received. In this case, imagine that we're going to talk about it later, but imagine we have our plant app, and we have selected the picture of a plant. We're sending it up to the server, and then we're waiting for the results. This symbol, or having a rectangle cut in its shape, shows that we're making a request, an external request, and then the information is coming back, and then we're going to be able to continue. And we can also interrupt with the interrupting edge symbols. So with those, the user will be able to cancel and finish the activity midway. So if something happens, we can interrupt, and we can represent the interruption with those thunder symbols. And this is, we can see the swim lines, which is basically a group of related activities represented into one column. And we can see a symbol that we already recognize in the top left corner. The customer starts the activity, and at the same time, other activities are happening, and they converge to the end here at the close of the order. And a very important symbol is the endpoint symbol. So as we have the single dot represented in the beginning of these activities, here we have the endpoint with a dot. It is a dot with a circle. So activities have a beginning and an end, and this is how we represent the end of the activity. Okay, so let's have an example with our plant identifying app. So let's say we have our user. Our user begins this activity by logging in into the app, and then in a home page, the user is going to select the option to identify a plant. This user is going to select a photo or take a picture, do whatever function is available to select the image of the plant. Then the app is going to request the matches. So this is an external request. That's why we use this specific shape, and we're going to have a response. So we're going to receive those matches, and then we're going to display the results, and we're going to end the activity. So this might be obvious for people that have been working with the app already, but having those symbols within the activity diagram, we can be extremely clear about what is happening.
Okay, so James did an excellent job of going over some of the general things about UML activity diagrams. I just wanted to talk about the upsides and downsides of this method. So the first really big upside, as you probably saw with James's presentation section, is that it can give you a really thorough visualization of a particular use case, which is incredibly useful for, especially for a lot of business cases. And it's a very advanced workflow. You can look at a lot of different types of interactions between or within an activity, which works really well for presenting things that otherwise might be difficult to visualize. So that kind of ties in with the thorough visualization. It's also really clear and simple. And this is kind of surprising, or was kind of surprising to me to realize was an upside, because when I first started interacting with these, they looked so complex. There's so many shapes, so many different types of arrows, so many different things that mean something. And so I did add a caveat that once you know it, it's really clear and simple. It is kind of just like anything, something that you have to learn. But once you learn it, it's really easy to really clearly see what's happening in that diagram. So, of course, there's some downsides. And like I mentioned in the previous slide, it can be really daunting the first time you look at these, because it just seems like this really special kind of archaic, or well, maybe not archaic, but esoteric way of looking at an activity. So it does take some getting used to, and the more you use it, the more you can, or the better you can read it. And then because it is so simple and so easy to diagram out a bunch of different use cases, scoping can become pretty complex, because there's this tendency to say, well, it's simple to put it down, so let's just put everything in the document. And then you get these overly heavy diagrams that aren't actually useful for portraying what you intended to in the beginning. They also can't represent any complex logic, lifetime behavior, or relationships between objects. Those are better for some different types of UML diagrams, like state and relational diagrams. So there's also some amount of vagueness and misinterpretation that can happen depending on how you actually build your activity diagram. There are certain indicators within the UML activity diagram code, and I use that in the term of a specific thing that means something else, that can be not totally clear in terms of how they're describing the relationship. So those are some basic downsides. But ultimately, if you're trying to convey a workflow or analyze a use case, a UML activity diagram is an excellent option. There's really nothing else like it for that particular problem. But it is not for seeing, like I said, how objects interact, or for complex logic, or the behavior of an object over time. You're going to want to use something different for that. With that being said, we have some sources that we used that you can see here if you want to learn more. Thank you.